Alright, welcome back. In this video, we're going to go over what you need to know for geometry, some basic geometry. And going to start off with a lot of definitions. So, first off, when we're talking about geometry, a point is something that has 0 dimensions. It's basically a location in space. It's represented by a dot, but again, a point has no length, no width. And usually we're going to label points by capital letters. We can have a line, which is 1 dimension. That means it goes off in one direction. And usually we put arrows at the end to show that it's infinite. So it goes all the way to the left and all the way to the right. And if we have 2 points, there's exactly 1 line that goes through that in Euclidean geometry. And so here is a line that's going through AB, and we would call this line AB. A line segment is part of a line with 2 endpoints. So if we just cut it off here, and there's point A and there's point B, then we have a line segment AB, which we just put a line over like that. An array is part of a line that has 1 endpoint, and then goes off in one direction. Let's use some different letters here. So we can say that this is CD, and we can label it like that. Planes and plane figures are 2-dimension, and usually, again, they're going to have some points. So we can have all kinds of planes that we're going to talk about, different shapes. So again, we could label those by a capital letter, maybe like R or P. And space and solids are going to be 3 dimensions when we start talking about cubes and pyramids and cones. They're going to have length, width, and height. We're also going to be using parallel lines and intersecting lines. So 2 lines are parallel, means that they're never going to cross and they're in the same plane. So here's a line L, here's a line M. Usually we'll show that those lines are parallel by putting like a little arrow on top of it. In this case, this little red arrow means that these lines are parallel. And then we can write that line L is parallel. Oops, that should be we'll write that again. Line L is parallel to line M. And if 2 lines are not parallel, if they're in the same plane, then they're going to intersect, and they'll intersect in exactly 1 point. So here, these 2 lines intersect, and they're going to intersect in exactly 1 point. One thing you're going to have to know is the different types of angles and relationships between angles. So an angle is going to be formed by 2 rays that have a common endpoint. So we have a ray here, we have another ray that comes from the same endpoint, and this is going to give us an angle. And let's just label some points here, like so. And this angle we can label in a couple different ways. Since there's only really 1 angle here, we could say that this is angle A. And what we're talking about is how far apart these lines are, how many degrees we have to rotate. It's kind of like a door that's opening. How far do we have to turn in order to get from this ray to this ray? And in this course, we're going to be measuring angles by degrees. So 360 degrees is going to go all the way around. And so this angle, if we were to measure it, maybe it's 30 degrees. We can, again, label it as angle A, or we can label it as angle CAT, angle CAT, or as angle TAC. So if it's labeled by 3 letters, the middle letter is going to be the vertex. So the vertex here is this point where the 2 rays come. Or sometimes we'll put like a little number there. So we could also, if we put a 1 in there, we can say that this is angle 1. And we're always talking about the smaller angle inside. Actually, there's an exterior angle here on the outside as well. But if we say angle A, we're always talking about the smaller angle and not the exterior angle. One special type of angle is a right angle, and that's kind of forms an L shape, and that's going to be 90 degrees, and we're going to know that it's 90 degrees if you see a box. In general, if that box is not there, we don't know for sure that it's a 90-degree angle. two lines that intersect and form a right angle are going to be called perpendicular. So here's a line going this way, here's a line going this way. Right now we don't know that they're perpendicular, but if you see that little box there, then we can say that we call this L and this is M. L is perpendicular to line M. And the symbol for perpendicular is an upside down T. And so now we know that this angle is 90 degrees, and since that angle is 90 degrees, all these other angles would be 90 degrees as well. An acute angle is one that is less than 90 degrees. So any angle that's smaller than 90 is going to be acute. So if you take your hand like this and you form an L, that's 90 degrees. And then if you don't have to stretch your thumb and your finger so far, that's going to be an acute angle. Anything that's less than 90 degrees. An obtuse angle is going to be one that's more than 90 degrees. So if it's a big wide angle, that's going to be obtuse. To remember this, acute, I think of something that's acute, it's sudden, it's sharp. So acute angles are the small, sharp, sudden angles. Obtuse angles are the big, obese type of angles. Obtuse kind of sounds like obese. And then a straight angle is one that's basically a straight line and then looks like 180 degrees. So if it's just a line that goes straight across, that's a straight angle. Now we come into some relationships between two angles. So complementary angles are going to be two angles that together add up to 90 degrees. Now the angles don't have to be right next to each other, but most of the time that you see this relationship, you're going to have something like this. You're going to know that there is a right angle here. It'll mark it with a little box. And then we'd have this line over here. So we know that this angle and this angle, maybe we call this angle 1 and angle 2. Angle 1 and angle 2 would be complementary because they add up to 90 degrees. Of course, again, they don't have to be side by side and have this common side. You could have, an angle here and then another angle over here. And if these angles add up to 90, they're also complementary, but it's a little bit harder to tell unless we know what the angle measures are. Supplementary angles are going to be angles that add up to 180 degrees. So usually when you are determining if something is supplementary, you'll see a straight line, and then you'll see another ray coming off of it like this. And so you'll know that these two angles here are supplementary. They're going to add up to 180. So this angle, if it's 60 degrees, then we know what this angle is because this would be the supplement of 60. So we take 180 minus 60. And that's going to give us 120. Vertical angles. Vertical usually means like straight up and down, but vertical angles don't have to be straight up and down. Vertical angles are formed anytime we have intersecting lines like this, and they intersect at a point. And we can see that there's lots of angles that are formed. So for example, vertical angles, these two angles right here are going to be vertical angles, and vertical angles are going to be congruent. So if we know that this is 30 degrees, on the right side, then this angle over here also has to be 30 degrees. And the last relationship on this slide is adjacent angles. Adjacent angles have a common endpoint and a common side. So we have a common endpoint. We draw off some rays here, and then like that. So angle 1 and angle 2 here are adjacent. It's a pretty weak relationship. Hopefully you can also see that complementary angles like we have up here are also adjacent, but it's a stronger relationship between the two of them. There's more information that we know if they're complementary. Adjacent, all we know is that they're side by side. And so if we know that this is 20 degrees, we don't know too much about this angle, angle 1. We'd have to know some extra information. However, if we know the exterior angle out here, say that's 300 degrees, then we would be able to find angle 1. So because we're going all the way around is how many degrees? That's right, it's 360 degrees. So if we take 360 minus 300 minus 20, what would be left? Well, the missing angle here would have to be 40 degrees. So now if we have the exterior angle, we'll be able to find the missing angle. One thing that you're going to have to do is do some angle addition and angle subtraction and get used to the notation for angles. So let's look at a couple examples here. This one says angle NDE is equal to 76. So remember how angles are labeled. This is NDE. Let me change colors here. Let's make this blue, a lighter blue. So this is NDE is going to be this angle right here. And that's 76 degrees. And then we will highlight this one into red. Sometimes highlighting it or outlining it helps to see where these angles are. CDN is going to be this angle right here. And that's 92 degrees. And then we say, okay, what angle do we want to find? We want to find CDE. So that's this angle here, CDE. So CDE is the big angle that's formed by adding the two smaller angles together. We know what the smaller angles are. So if we have two small angles put together, they're adjacent, they're going to make up the big angle. We just add the two together. So if we add 92 and 76, what do we end up with? 2 and 6 is 8, 9 is 7, 168. So 168, that seems like because that's a big obtuse angle. So that would come out to 168 degrees. For number 3, it says find EFC. Where is EFC? That's this smaller angle here. If EFG is 102. So here's EFG. Now we have the big angle, and that big angle is 102 degrees. And we are given CFG, that's this angle, CFG, that's 70. Now we're given the big angle and one of the smaller angles, and we have to find the other small angle. So here's the other slice that we need to find. So in this case, we need to subtract. So we're going to have to subtract 102 minus 70. And that will give us the small angle, because now we have the whole and we have one of the parts. We have to find the missing part. So if we subtract this, we would get 32 degrees. 32 degrees and 70 degrees is a total of 102 degrees. So when you're given two small angles and you have to find a big angle, you're going to add them together. And if you're given a big angle and one of the smaller angles, one of the parts, then you're going to have to subtract to find the other part or small angle. Okay, one thing that you're going to have to do is also to classify angles as acute, obtuse, right, or straight, based off of appearance and based off the angle measure. So when you're looking at appearance, I said usually if it's a right angle, you're going to see the little box. But for this case only, if it looks like a right angle, we're going to call it a right angle. So for number 1, which one does that look like? Well, it doesn't look like it's a right angle. It doesn't look like it's a perfect L. It looks like it's a little bit smaller. I don't have to open quite as wide. So this one's going to be acute. Number 2 does look like an L. It looks like these lines go together at 90 degrees. Now, technically, it could be like 89 degrees or 91 degrees, but it looks closest to a 90-degree angle. Even though it doesn't have the box there, we're going to label this a right angle. So if it looks like an L, maybe that L is going the other way here, it's going to be a right angle. Now this angle, number 3, is bigger than 90. It's wider. I'd have to stretch really far to make it so that, remember, is our obtuse angle. And the last one here is a straight angle. So you can do it based off appearance. You can also do it based off of the angle measure. If it's 82 degrees, that's less than 90. That's going to make it acute. 90 degrees, that's exactly 90 degrees. That's going to make it right. 180 degrees, that's a straight angle. And 104, that's going to be an obtuse angle. There's some extra practice there as well. The next thing we're going to do is just go through some, forgot, the linear pair is another word for complementary. So back on this page before, we're talking about complementary and supplementary. Supplementary, another name for that is linear pair. So complementary, linear pair, or supplementary mean the same thing, pretty much, that they're going to add up to 180. Vertical or adjacent. Okay, number one. Notice here we see the little box here. So that means that they're going to be complementary. That means that A and B are going to together add up to 90 degrees. I'm just going to abbreviate it, complementary. Number three. Here we see two angles that are across from each other. We see two intersecting lines. So these must be vertical angles. Number two over here, A and B, side by side. No other special characteristics, no box. It doesn't form a straight angle. So this must be adjacent. And usually I'll just abbreviate it like that. And number four, this does form a straight angle, straight line. So here's our straight line, and we can see it's divided up into two. So this is going to be a linear pair or supplementary angles. Now we can use that to find the angle measures as well. So number one, what type of angles do we have here? Well, again, we see the little box here, so these would be complementary. And we know complementary angles are going to add up to 90 degrees. So if we want to find the missing angle, we're going to take 90 minus 44 and do the math here. And that should come out to 46. So the missing angle here is 46. For number two, here we have two adjacent angles. And remember, for adjacent angles, we also have to know this exterior angle if we have to find a missing angle. So here we're going to take 360. We're going to have to subtract off 293 and then subtract off 36. So let's go ahead and do that. Let's subtract off the bigger one first. So if I subtract off 293, I have to borrow here, and looks like that gives us 67. So 67 is what's left over after we subtract off 293, and then we subtract off 36, and we're going to be left with 31. Always make sure that your answer looks reasonable. A lot of times these pictures are drawn pretty close to scale. And for number three, these angles are supplementary. So supplementary angles have to add up to what? They have to add up to 180 degrees. So we're going to take 180, subtract off 40, and that's going to give us 140. And you can see that we're left with a bigger angle here. So that's going to be 140 degrees. So that's how we find missing angles. And of course, if they're vertical, like we have for number 6, these are vertical angles. Vertical angles are congruent. So you know right away that they're going to be the same thing, 69 degrees. The next thing we're going to talk about is the angles that are formed by parallel lines and the angle relationships that we get from parallel lines. So in this picture, let's label this L and let's label this M. Let's say that L is parallel to M, and usually to show that they're parallel, we look for these little arrows that will be on the lines themselves. We'll label this guy T. That's called a transversal. Transversal means it's cutting across. And from this picture, we have all kinds of angles on this picture. So we can label these. How many angles are formed by two parallel lines and a transversal? We've got 1, 2, 3, 4, 5, 6, 7, 8. And there's all kinds of relationships, new relationships that we get. So the first one that we're going to talk about is alternate interior angles. Alternate interior angles. Now let's break this up. Let's think about what the word what the phrase alternate interior can mean. So let's take interior. What does interior mean? Okay, well, interior means inside. What angles are inside? What are they inside of? What angles are inside? If you said 3, 4, 5, and 6, you're right. Those angles are inside the parallel lines. So when we're talking about alternate interior angles, we're talking about the angles that are first off inside the parallel lines, or enclosed. So you can see here 3, 4, 5, and 6 are kind of inside the parallel lines. And now angle 3, we want the alternate part. The alternate part means that it's not going to be right next to it. Okay, it means that I got to go across the transversal to the other side. Now 3 and 4 are not alternate interior because those are supplementary. So I got to go across and then down here to number 6. That's the alternate interior angle. And if you look at angle 3 and you look at angle 6, you should see that they look like they might be the same. In fact, angle 3 and angle 6 are congruent. And this little equal sign with a little squiggly above it is the symbol for congruence. Congruence means that they're exactly the same. So when we say that two things are congruent, we mean that they exactly match up in shape or size. So angle 3 is congruent to angle 6. Those are alternate interior angles. We got another pair of alternate interior angles. Which ones would those be? Well, again, we said they're inside. So what's another angle that's inside? We got angle 4, and the alternate interior angle to angle 4 would be angle 5. And again, those two angles, 4 and 5, are going to be congruent. And those are the only ones that are inside the parallel lines. The next relationship we've got is alternate exterior. So alternate exterior. And again, break this up. What does exterior mean? Exterior means on the outside. So these are lines, these are going to be angles that are on the outside of the parallel lines. Which angles are in the outside of the parallel lines? If you said 1, 2, 7, and 8, you are correct. And again, let's take one of these angles. Let's take angle 1. What angle is going to be alternate exterior to it? Now, it can't be angle 2 because those are supplementary, so those already have a relationship. And it can't be angle 7 because we got to go alternate. We got to go across the transversal, so we got to go down to number 8. Angle 1 and angle 8 are alternate exterior. So this guy right here and this guy down here are going to be alternate exterior. So angle 1, angle 8, alternate exterior. What's another alternate exterior angle? Another angle on the outside would be angle 2. And we have to go across the transversal, but it's not angle 1, it's going to be angle 7. Angle 2 and angle 7 are alternate exterior angles. So that's our second relationship. The next relationship that we have from parallel lines is called corresponding. Corresponding. And mathematically, corresponding means matching. So we want angles that kind of match up. Imagine taking an angle and being able to slide it left, right, up, or down. We're not going to twist it or rotate it at all. We're just going to slide it. So look at this angle 2 that's formed. And look at the direction that it goes. Here's what angle 2 looks like. If I slide it up, this is what angle 2 would look like. It would look kind of like that. Kind of looks like an arrow that's pointed down. And where could I slide this shape to so that it fits? I can slide it down. I can slide it over this way. Do you see any other angle that's going to match up to that same shape? Angle 6 has that same shape. It's also kind of like a little arrow or wedge that's shaped, that's pointed down. So angle 2 corresponds to angle 6. They're going in the same direction. The angles are going to open up, and the arrow is pointed down. And if I shift it left or right, up or down, they're going to match up. So that's what corresponding means. Corresponding means matching. So they have to be an exact match just kind of like moving the puzzle pieces around. So angle 2 would fit in exactly to angle 6. Let's look at another one. So angle 4 looks like a little wedge or arrow that's pointed to the left. And where does that match up to? So that it's pointed in the same direction. Again, I just can slide that piece. So imagine it being like a puzzle piece. Where could I slide it so that it fits? Well, angle 4 is going to correspond to angle 8. So right down here. This is also a wedge or an arrow that's pointed to the left. There's more corresponding angles. What else corresponds? Well, angle 1 corresponds to what angle? Angle 1 corresponds to angle 5. And we have one more. Angle 3 corresponds to angle 7. And of course, as I'm writing here, all corresponding angles are congruent. So if you know one of the angles, then you know the other angle. The last relationship is same side interior. Same side interior. Let me erase these guys. So our last relationship is called same side interior. So we're back to this word interior, and we know that interior means inside, and in this case, it means inside the parallel lines. So angle 3 is inside, but this time it says same side, not alternate. So same side of what? Well, the same side of the transversal. So this time we don't go across the transversal road. So which angle is also inside the parallel lines and on the same side of the transversal? Well, we'd have to go down to angle 5. So angle 3 and angle 5 are same side interior angles. Now, are these the same shape? No, they're not exactly the same shape. If you look at angle 3, that's a big obtuse angle. And angle 5 is a small acute angle. But they do have a special property. When you add them up, what do you think they're going to add up to? They're going to add up to 180 degrees. So if we do know that angle 3 is 100 degrees, then angle 5 has to be 80 degrees. So if we know one, then we know the other. There's another pair of same side interior. We've got angle 4 and angle 6. And again, when we add up same side interior angles, we're going to get 180 degrees. So those are the new relationships that we get when we have angles formed by parallel lines. Alternate interior, inside, across and transversal, they're congruent. Alternate exterior, they're outside, but again, across the transversal, they're going to be congruent. Corresponding means that they match up. There's lots of corresponding angles. It means that you slide and match them up. And then same side interior, again, they're on the inside, and they're going to be on the same side. And then on this slide, I just show all the different relationships that these have. So we can have alternate interior, alternate exterior, same side interior, corresponding. We've talked about vertical. 1 and 4 are vertical. 5 and 8 are vertical. And adjacent, or the ones that are supplementary, are also on there. So next thing we want to do is to identify these relationships and then use that to find missing angles. So let me work out some of these for you. So number 1, which of these relationships does number 1 have? Is it corresponding? Is it alternate interior, alternate exterior, same side interior, vertical, or adjacent? Well, if you look at these two angles, they're on the outside. Okay, so that means that it can't be the alternate interior and it can't be the same side interior. They're both on the outside. Do they match up? Can I slide one into the other? No, they're going in different directions. This one is pointed that way, this one is pointed that way, so they're not corresponding. They are on opposite sides of the transversal, so these would be alternate exterior angles. For number 2, the two angles here are both inside and they are across the transversal, so these would be alternate interior angles. X and Y, in this picture, I don't even really need this line. In fact, I could erase the bottom line here. Imagine that I just like scribble this out. Just scribble out this way. I don't need this line down here. So this relationship here doesn't depend on the parallel lines. These two are adjacent, or even better yet, we could say that they are supplementary, or they're a linear pair. And then for number 4, these two are interior, and they're on the same side. So this would make them same side interior angles. Now we're going to use those relationships to find missing angles. So number 1, I'm going to identify the relationship and find the angle measure. So for number 1 here, look at this angle here, look at this angle right here. Which relationship do we have? Well, we have one angle that's on the inside, one angle that's on the outside. So, and we can slide it. If we just slide this arrow up and to the left, they would match up exactly. These are going to be corresponding angles. And so the missing angle here has to be 50 degrees because corresponding angles are congruent. Number 2, we have an angle on the outside. The missing angle is also on the outside. They're across the transversal. So these would be alternate exterior angles. And alternate exterior angles are congruent. So this would be 120. Number 3, here are the two angles. Notice that I don't even need this bottom line or this bottom half. I could just cut off this. All I need to do is look at this part of the picture. It only depends on these two lines. It doesn't depend on the other line, the other parallel line. We have two intersecting lines. The angles are across from each other. These angles have to be vertical angles, and vertical angles are congruent. So it has to be 160 or 106 degrees. And number 4, these two angles are inside the parallel lines, but they're not across the transversal. So these would be same side interior angles. And same side interior angles add up to 180 degrees. They're supplementary. So same side, we have to take 180 minus 74 and do the math there. We get 106 for the missing angle. We'll do a few more here. Let's look at number 5. So in this example, just like in the vertical example, I don't need this part of the picture. All I need to do is focus on these two lines. And if you notice, they're right next to each other. They're adjacent, or even better yet, they are supplementary or linear pair. And I could say that they're adjacent too, but if I'm asking you for a relationship, I want the strongest relationship that they have. And for supplementary, they're going to add up to 180 degrees. So to find the missing angle, I'm going to take 180 minus 78, subtract, and the missing angle here would be 102 degrees, which makes sense because it looks like an obtuse angle. For number 6, these would be corresponding. And it looks like these angles are the same. If you notice that all the big angles and all are equal to each other, all the small angles. So here we have a small angle, here we have a small angle. So small angles are going to be congruent to each other, big angles are going to be congruent to each other. So if it looks like it's the same, it's probably going to be the same. So this one's going to be 60. These are both alternate exterior angles. And the last one here, these are also alternate exterior angles. And this would be 45 degrees. All right, in this next section, we're going to start talking about triangles and properties of triangles. Some basic definitions as we go through talking about triangles. First off, a base is going to be one side of a triangle. We're going to use this more when we talk about area of a triangle, but Let's draw a triangle. Triangle has 3 sides, 3 angles. So here's a triangle, and a lot of times we say that the base is on the bottom, but the base does not have to be on the bottom. If we draw the base on the bottom, though, the height of the triangle is going to be a perpendicular line to it. So the height sometimes is not even a side of the triangle. It's just going to be how high does the triangle go from whatever we consider the base to be. The base and the height for a triangle have to be perpendicular to each other. So I could draw a triangle like so, and if I call this the base, then my height would be going this way. So that would be the height. So the base of the triangle does not have to be on the bottom, but the base and height would have to be perpendicular. The angles of a triangle have to add up to 180 degrees. So imagine we got a triangle like this, and maybe this is 110. Maybe this angle over here is 40 degrees. So what does this missing angle here have to be? Well, 110 and 40 is it adds up to 150. So the missing angle here would have to be 30 degrees. All 3 angles in a triangle have to add up to 180 degrees. Now we're going to classify triangles. So we can classify triangles based off of their angles or off their sides. So the first big type of triangle is called a right triangle. You're going to know it's a right triangle because just like with right angles, it's going to have it marked and it's going to have a little box here. That's telling you that that angle we know is exactly 90 degrees. And this hypotenuse is going to be across from it. So the hypotenuse for this triangle is this side over here. It's going to be the longest side across from the right triangle. We can also have a triangle where all the sides, all the angles are less than 90 degrees. So an acute triangle like that, all the angles are less than 90. And then you could have an obtuse angle that has a big angle. It's going to have exactly one angle that's more than 90 degrees. Now it can't have 2 angles more than 90. So if this angle is more than 90 and we have another angle that's more than 90, then the triangle can't even close up. So that's not possible. It's not possible for a triangle to have more than one angle that's 90 degrees or more than one that is more than 90 degrees. So at most it's going to have an angle that's more than 90 degrees. So that's how we classify triangles based off the angles. We can also classify triangles based off the sides. If all 3 sides are congruent, then we're going to have an equilateral triangle. You're going to know it's equilateral because the sides are going to be marked. When we put a little slash, a little dash on them, that's telling you that all the sides are the same. So even if it doesn't look like it's quite the same, since I put a dash on each of these line segments, that's telling me that they should have the same length and it should be equilateral. Now for equilateral, it also happens that equilateral is equiangular. So all the angles here are going to be the same. So all the angles are going to be the same. If all the angles add up to 180, that means that each angle here has to be how much? All the angles are the same. All the angles add up to 180. Each of the angles is going to be 60 degrees. 60 plus 60 plus 60 adds up to 180. So all equilateral triangles are also going to be acute because, well, all the angles are acute. Isosceles triangle is going to be a triangle that has 2 sides that are congruent. So here's what an isosceles could look like. It could be an obtuse isosceles. And again, when it's marked, you're going to see 2 sides marked that are the same. And if 2 sides are the same, then it's also going to have 2 angles the same as well. So these 2 base angles would be the same. This is an example of an obtuse isosceles. You could also have an acute isosceles. So, maybe I draw like this, like that. Now it's an acute isosceles. I've put a mark here, put a mark here. Now I know it's isosceles. These angles would also have to be congruent. And then a scalene is one where all the sides, let me try to draw that again. All the sides are going to be different. So there are no congruent sides. So something like this. So for a scalene, you're probably not going to see any markings. Or if I did mark it, I'd have to mark this with 1, this with 2, and this with 3 to show that all the sides are different. All right, here's some examples. You're going to classify a triangle by its angles and its sides. So we're going to classify these by their angles and by their sides. So for number 5, first thing you should look for is the angle. Does it have a right angle, or does it have an obtuse angle, or are all the angles small? Well, for number 5, I don't see any right angles, but notice here, I've got a big obtuse angle. It only takes one, and the triangle is obtuse. So you first pick whether it's going to be right, obtuse, or acute. So you pick out the angle relationship first, then you decide if it's equilateral, or if it's isosceles, or if it's scalene. So you give it a name from each. You name it by its angles, you name it by its sides. So this is obtuse. And then if I look at the sides here, these two sides are the same. So this would be an obtuse isosceles triangle. For number 6, see that it has a little box right here. That's telling me that that's a right angle. Then I look at the sides. None of the sides are marked. So that means that all the sides have to be different lengths. That means it has to be a right scalene triangle. For number 7, what do you think number 7 would be? Do you see a right angle? Do you see an obtuse angle? There is an obtuse angle. It's down here. And it only takes one. And now it's an obtuse triangle. Now you look at the sides. Do you have any sides that are the same? This one, none of the sides are the same. So this would be an obtuse scalene. For number 8, I don't see a right angle. And this angle is acute, this angle is acute, this angle is acute, so it must be an acute triangle. Then I look at the sides. This side and this side are the same. It's got 2 equal sides, so that makes it an acute isosceles triangle. Number 5, no right angle. Look for an obtuse angle. This is acute, this is acute. Oh, here's an obtuse angle. It's bigger than 90. You got to stretch it pretty far. So there's an obtuse. And then I look at the sides. 2 sides are the same. This is another obtuse isosceles triangle. Number 6, look at the angles. It's got a right angle. So that makes it a right triangle. Look at the sides. 2 sides are the same. So it's isosceles. This is a right isosceles triangle. Number 7, no right angle. Acute, acute, acute. All the angles are acute, so it's acute. Look at the sides. No marks, no marks, no markings at all. So all the sides are different. This is an acute scalene. Number 8, look at the angles. All the angles, there's no right angle, no box. All the angles are equal. That means they're all 60. So this has to be an acute triangle. Look at the sides. 1, 2, 3. Oh, 3 sides are equal. It's got to be an acute equilateral. Now, I said that's kind of redundant because if it's equilateral, it has to be acute. So sometimes it might just say equilateral. And you know, obviously, that an equilateral triangle is going to be acute. So you might not see the word acute in front of it, because for it to be equilateral, it has to be acute. Find the missing angle. So remember, all the angles to a triangle add up to 180 degrees. So find the missing angle. 50 and 70. What does this have to be? Well, 50 plus 70 is 120. Subtracted from 180, the missing angle has to be 60. Number 2, here's a right angle. So how much is that? That's 90. This is 30. 30 plus 90 is, again, 120. 180 minus 120, 60 degrees. So this missing angle also has to be 60 degrees. Number 3, find the missing angle. We know what two angles are. We want to find the third. So we add up the two angles. And that gives us 144. Subtract it from 180. That gives us 36. 36 plus 65 plus 79 adds up to 180. These are pretty simple, but we can also solve for more complicated triangles if we have a couple different theorems. So here's a picture. We know that the sum of the angles in a triangle add up to 180. So 3 angles here, A plus B plus C, have to add up to 180. Sometimes we're going to extend some lines. So we might have vertical angles. We might have some supplementary angles as well. So supplementary angles, like C and D, this angle on the outside, is going to add up to 180. And we might have exterior angles. So you could prove that, this one's a little shortcut. So angle D here, this angle on the outside, is going to be the sum of these two. Let's just prove that a little bit. So let's say that, if this was, we'll say 30 degrees, and this looks like it's big, and let's say that this is 140 degrees. What does angle C have to be? Well, 30 plus 140 is 170, so that means that C would have to be 10. What does D have to be? Well, C and D are supplementary, so this would have to also be 170. So D here is going to be the sum of A and B. So you could use that as a shortcut. The other thing I want to point out is imagine that we extend this. So sometimes you might have to use another type of angle. And say I have E out here. What do you know about E? Well, C is going to be congruent to angle C and angle E are going to be congruent. So that means that they're going to be the same because we got vertical angles. So when you have these triangle pictures, look for vertical angles, look for supplementary angles, and know that all the angles inside of a triangle add up to 180. So let me go through a couple examples. I want to find the missing angle, the question mark here. This is on the top. So if I want to find this angle here, that means I probably have to find this angle that's inside the triangle first. But to do that, I have to fill out the rest of the triangle. So we got to fill in all the information that we know. So what do I know about this angle down here? It's a linear pair with the 80 degrees. These two angles are going to be supplementary. Means that they have to add up to 180 degrees. So this angle here would have to be 100. Now, if you use the shortcut, you could skip right to this angle because this is an exterior angle. But let me just fill out the rest of this. So you could also find this angle inside here. 55 plus 100 is 155. So what does this angle inside have to be? Well, all the angles inside have to add up to 180. So 55 plus 100 plus whatever this is better add up to 180. So if we take 180 minus 155, that is going to come out to 25. So this angle has to be 25. And then if I want to find the angle on the outside, I would take 180 minus 25 because they're supplementary, and that would give me 155. So here I get 155. Now remember, I said you could have skipped this part because this 155 you could also just got from adding these two together. But if you want to be more thorough, just fill in all the angles and make sure that everything is consistent. All the angles inside of a triangle are going to be adding up to 180. All supplementary angles are 180. All vertical angles are congruent. And that's how you can find the missing triangle. make sure your answer makes sense too. It looks like we've got a big angle on the outside here, an obtuse angle. If I got an answer like 60, I would know that that wouldn't make sense with what the picture is showing me. Here's number 7, another example. Here we want to find the missing angle inside of a triangle. To find this missing, we need to find these two angles inside the triangle. So we have to work our way inside the triangle. Now notice that this angle and this angle are what type of angles? Those are going to be vertical angles, so those are going to be congruent to each other. So if this is 43, then this angle has to be 43. So remember, in these types of problems, we can use vertical angles, we can use supplementary angles, and we can use that the angles in a triangle add up to 180 degrees. Those are basically the three things that you're going to have to use in order to find the missing parts here. Now we can find this missing part. Well, these two angles up here are going to add up to 180. So 180 minus 87. I need to do some subtraction here. Comes out to 93. Now I know two angles, so I can find the third angle in the triangle. 93 plus 43 adds up to 136. And I subtract from 180. And that should come out to 44. So that angle looks like it's going to be 44 degrees. And that seems to make sense with the picture, and I can check 44 plus 43 plus 93 adds up to 180. These pictures, a little bit more complicated, but you do the same thing with them. Okay, so let's just do one example here. Actually, let's go down here to number 12. I like this one here because it's got some extra notation. So we got to work our way all the way here to the right. You're not going to have one this complicated, but if you understand the steps here, you can do the much simpler ones. So I want to find this angle. To know that angle, I need to get this angle. To know that angle, I need to know this one. So you got to work our way back here. So let's start with what we do know and fill in the picture. So if this is 35 degrees, then I know what this is. This has to be 35 degrees. Now I can find out what this angle is, because the three angles inside this first triangle on the left side have to add up to 180. Well, this is 35 and this is 100. So together they add up to 135. Subtract that from 180 and I would get 45. So now this angle is 45. This angle, it doesn't say it, but it's marked as a 90-degree angle. Now I can find this little angle inside the right triangle. It's not a right triangle, it's a triangle on the right side. So 45 plus 90, that's 135. Subtract it from 180. And this angle is also going to be 45 degrees. So now I can find at last the missing angle that I want to, because now I know these two angles, 60 and 45, which adds up to 105, subtracted from 180, and that's going to give me 75. And that looks like it's about a 75-degree angle. So that's it for triangles. Now we're going to do quadrilaterals, and then we'll do solids. So you're going to have to identify quadrilaterals, and here are the definitions. And then we'll do a little tree diagram for them, and then some practice. So a parallelogram is going to be a quadrilateral. Quadrilaterals are plane figures that have four sides. Parallelogram is going to have two pairs. Now we're going to go over how to classify quadrilaterals. Quadrilaterals are plane figures that have four sides, and that's it, four enclosed sides. We've got some special quadrilaterals, though, that you're going to have to classify. So the first one is called a parallelogram, and that means it's going to have two pairs of parallel lines. So you're going to know that they're parallel because they're going to be marked with little arrows on them, like so. So maybe that has two arrows going that way, and this has one arrow going this way to show that they're parallel. A rectangle is a parallelogram with 4 right angles. So we get a little bit more specific here. Rectangles have 4 right angles. So you're going to see the little boxes in those. A rhombus is a parallelogram that has 4 equal sides. So you're going to notice a rhombus when you see the dashes on the sides. And a square is both a rectangle and a rhombus. So it's got 4 equal sides and 4 equal angles. A trapezoid has only 1 pair of parallel lines. So it's going to be marked like that. And an isosceles trapezoid looks like a trapezoid, looks like an isosceles triangle basically that's cut off. So these sides here are going to be equal. So imagine that you start with a triangle, and that triangle is isosceles. And then if you cut the top half off, oops, then it would kind of look like this, and you would have an isosceles trapezoid. And then a kite has 2 pairs of consecutive sides that are congruent. So these sides down here would be congruent, and these sides up here would be congruent. So here's a little bit better picture, tree diagram or Venn diagram. So at the top here, all 4-sided figures are quadrilaterals. And then as we go to left and down here, we get more specific. A parallelogram has 2 pairs of parallel sides. You can see they're marked parallel. From there, you can have parallelograms that are trapezoids, or here we have a Venn diagram showing us the relationship between all these. At the top here, we have a quadrilateral. And then as we go to left, we get a little bit more specific. So parallelograms have 2 pairs of parallel sides. And a parallelogram that has 4 right angles is a rectangle. A parallelogram that has 4 equal sides is a rhombus. And if it's both a rectangle and a rhombus, all the sides are equal, all the angles are equal, then we call it a square. If it only has 1 pair of parallel lines, then it's called a trapezoid. And a little bit more specifically, if it has 2 congruent sides here, then it's called an isosceles trapezoid. And then our last one is a kite, which has 2 consecutive sides. 2 sides are next to each other that are congruent, and 2 other sides that are congruent, but they're not congruent to each other. Then we have a kite. So let's look at some examples. In these, we want to name the most specific name. So when it says the most specific name, that means the name that's furthest down on this tree diagram. Of course, these are all quadrilaterals, but we want to be as specific as possible. So if it has, here we have a quadrilateral, but it has 4 equal sides, so this is going to be a rhombus. For number 2, what do you notice about this one? It's got 4 equal sides. It's got 4 right angles, so it's both a rectangle and a rhombus, and that would make it a square. For number 3, notice that it's got the little arrows on it. It's got arrows on these 2 sides. It's got arrows on these 2 sides. So those arrows are showing us lines are parallel. 2 pairs of parallel lines gives us a parallelogram. For number 4, what shape does this look like? It's got 4 right angles. Right means rectangle. For rect here means right angle, basically. So that's our rectangle. For number 5, notice we have parallel lines, but it's only got 1 pair of parallel lines. So this is a trapezoid. But is it just a trapezoid? Well, it also has these 2 sides here that are congruent. So that means it's going to be an isosceles trapezoid. So we want to be as specific as possible. And the last one here is our example of a kite. So number 6 is a kite. Here's a list of how we label polygons based off their sides. So if it has 3 sides, we call it a triangle. If it has 4, we call it a quadrilateral. 5 sides is a pentagon. 5 sides is a pentagon. 6 sides is a hexagon. 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon. The other thing we're going to do is to label solids. So To label solids, we have basically two main types of solids. We have prisms and we have pyramids. So for a prism, basically what you do is you take a polygon, or you take a plane figure, and you take two copies of it. So if I want to make a square prism, I'm going to take two squares, and that's going to be like the top and the bottom of my box. So basically prisms are like boxes. So to make a square prism, I'm going to take two copies of that, put one on top of the other, and then I got to make the sides. The sides are going to be rectangles. So if you look at the top and the bottom, we call those the bases. So a prism has two bases that are going to be the same shape. Now they don't have to be on the top and the bottom, but here you can see a triangular prism has a triangle on the top, triangle on the bottom. Those are the two bases, and that gives us a triangular prism. The sides going around are all going to be rectangles. Here is a square prism. It's going to have a square on the bottom here. It's going to have a square on the top, and it's got rectangles going around it. That is a square prism. A rectangle, we got a rectangle for one of the faces. We got a rectangle for the other face. That makes the top and the bottom, and it's got rectangles going all the way around, so it's a rectangular prism. So prisms are basically like boxes, where the top and the bottom of that box could be a different shape, like a pentagon. We could have a pentagon on the top and a pentagon on the bottom, and we have a pentagonal prism. Or we can have a hexagonal prism. Prisms on the other, or pyramids on the other hand, have one base, and then they're going to have triangles for the sides that are going to fold up and come to a point. So notice that we have a point here, we have a point here. That point is called the apex of it. Here it's going, we got the base on the side here to the right. So we got triangles going around, but then you have one base, and that base is going to tell you the shape of the pyramids. So you can have square pyramids, rectangular pyramids, pentagonal pyramids, and hexagonal pyramids. So two main shapes, boxes or prisms and pyramids. And then these down here are the three special cases of cylinders, cones, and spheres. So basically a cylinder is kind of like a can. And the cylinder is similar to a prism where you have two circular bases on the top and the bottom. A cone is kind of like a pyramid where you have a circular base and then it comes together at an apex or at a point. And then a sphere, kind of looks like a ball, but we're going to call it a sphere. So you're going to have to classify the different shapes. So for number one, that looks like a sphere. For number two, this looks like a pyramid because we got it coming together at an apex here. So that's a pyramid. Now we got to tell what type of pyramid it is. So if you look on the other side, here is the shape to examine. What shape do we have here? Now it's a little distorted because we're drawing it a three-dimensional object on two-dimensional. So we've got a square here. You got to look at the markings. So you got four right angles, 4 equal sides. So this is a square pyramid. For number three, this looks like a box. So that means it's going to be a prism. And if you look at the base that's marked out, that's also a square. So here we have a square prism. Number four, this is an example of a cylinder. It kind of looks like a can where it has the top and the bottom as a circle. And number six is a cone. Here are a few more examples. For number seven, it looks like a box. So we're going to call this a prism. And the box is a rectangle, so we're going to call it a rectangular prism. For number eight, it also looks kind of like a box. The top and the bottom are triangles, so this is a triangular prism. You can tell it's a prism because it has two triangles. Here's a triangle, and then there's a triangle below it. So if it's got two exact copies of it, that makes it a prism instead of a pyramid. So this is not a pyramid, this is a prism. The same can be true for number 10. So this is also a triangular prism. So both of these are triangular prisms. Here we have a box shape. This is a prism. And we got to look at the top and the bottom, look at the base to determine which type it is. So it's got 1, 2, 3, 4, 5 sides. This is going to be a pentagonal prism. This one's 1, 2, 3, 4, 5, 6 sides. This is a hexagonal prism. That's where test 1 material is going to end.